Okay. So good afternoon, all of you. In last lecture, we have solved numericals on principal stresses. Okay, how to find out principal stresses and principal planes. Okay, and in last lecture, I have given one example for homework. Alright.
Yes, ma'am.
Yes.
Okay. So have you solved?
Yes, ma'am.
So now you tell me what is your answers.
Sigma 1, madam, major principal. 1049.09.
Wait. Yes. Sigma 1, which is equal to how much?
10449.09.
Sigma 1, which is equal to 1
049.
049. Any
Point
other point
09.
09. Any other have different answer?
Sigma 1 is equals to 1199.99.
11.
नाही मॅडम 1049.09 येते.
माझं पण मॅडम ते झाले 1049.09.
Okay, then before sigma 1, you tell me the value of stresses. That is the value of tau and sigma x, which is equal to how much, and tau, which is equal to how much.
Tau 4, madam.
So
400.
400 and sigma x 692.82.
Tau 400 and
Newton
sigma
per Sigma 692.82.
692.82.
692.82.
2.82.
Okay, good. Correct answers. Sigma x, which is equal to 692.82, and tau, which is equal to 400.
400.
Okay. So next is you have to find out.
Sigma 2, madam. Sigma 1 and Sigma 2.
Yes, sigma 1 and sigma 2.
2.
Okay. So 692.82 Newton per centimeter square, right? And 400 is Newton per centimeter square. Okay. So whenever you find sigma 1 and 2, which is equal to sigma x plus sigma y divided by 2 plus minus square root of sigma x minus sigma y by 2 bracket square plus tau square. Okay. In this equation, you have to put values. Okay. So sigma 1, which is equal to sigma x is 692.82 plus sigma y is how much? Already given, and the value of sigma
600.
y is 600. Okay. Divided by 2 plus minus square root of 692.82 minus 600 divided by 2 bracket square plus 400 square. Okay. So now you calculate and tell me sigma 1, which is equal to how much?
1049.09.
Okay, 1049.09 Newton per centimeter square. So this is correct answer. Okay, this is correct. And sigma 2, which is equal to how much?
243.73.
243.73.
243.73.
Newton per centimeter square. So this is also correct, sigma 2. After that, principal planes, that is theta 1, which is equal to how much? Theta 2, which is equal to how much?
Theta 1 is
76.92.
76.92 and theta 2 is
4.1,
166.92.
Please.
41.69, madam.
Yes, 41.69
69.
is correct. Theta 1 and theta 2 is
131.99.
131.99. Okay. Yes, this is also correct. Then next, you tell me maximum shear stress value, that is tau max, which is equal to how much? Tau max.
402.92. 98.
Okay, 402.98 Newton per centimeter square. And then direction for shear trace, that is theta 1, which is equal to, and theta 2, which is equal to.
theta 86.87 madam. Theta 86.69 theta 1
Okay.
direction
Okay, and theta 2?
and 176.69.
Okay, good. So all answers are correct. Other students got these answers or not?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the final answers. Major principal stress 1049.09 Newton per centimeter square. Minor stress is 243.73 Newton per centimeter square. Principal plane, that is major principal plane, theta 1 is 41.69. Minor principal plane, theta 2, which is equal to 131.99 degree. Then maximum shear stress, which is equal to 402.98 Newton per centimeter square. And directions, theta 1 is 86.69 and theta 2 is 176.69. Okay. So after that, I think next problem we have solved, right? Please check this problem we have solved or not. Here 280 value is given and here 140.
सॉल्व केलाय मॅडम तो
Okay, okay.
होमवर्कला दिला असतात
Okay. So our numericals on principal stresses, how to calculate principal stresses and principal planes are over. So today we will move towards strain point. Okay, so please write down next point. 2D principal strain. 2D principal strain. 2D principal strain. 2D principal strain. Okay, 2D principal strain. So first we will define what is meant by principal strain. Okay, so before moving this point, I will ask what is meant by principal stresses. Yes.
Change in volume upon original volume.
No, I am asking what is meant by principal stress.
Normal stress is acting
Upon-
on the principal plane.
Yes, normal stresses acting on the principal plane. This stresses is called as principal stresses. And what is meant by principal plane?
The planes which have no shear stress or zero shear stress.
Okay, good. So the plane which have no shear stress or zero shear stress, such a plane is called as principal plane. Okay, so now we have to discuss what is meant by principal strain. Okay, same. The normal strain, acting on the plane, acting on the plane on which there will be zero shear strain. There will be zero shear strain. Zero shear strain. So same way, normal strain acting on the plane. So suppose this is our block. On that only direct stress or normal strain is present. Okay, epsilon. Okay, epsilon D. So only here direct strains are present. Here shear stress is zero. So such strain is called as principal strain. Okay. So the normal strain acting on the plane on which there will be zero shear strain. Such a strain is called as principal strain. Okay. So this is the definition. Now we will see how to find out strains. So please write down equations. Epsilon maximum and epsilon minimum, which is equal to epsilon max and epsilon minimum, which is equal to epsilon x plus epsilon y divided by 2 plus minus square root of epsilon x minus epsilon y by 2 bracket square plus gamma into xy gamma xy divided by 2 bracket square. So here shear strain means gamma xy divided by 2 bracket square. So this is the equation. Okay, sigma x, this sigma indicates stress and epsilon indicates strain. That's why epsilon x plus epsilon y by 2 plus minus. Whenever you calculate maximum strain, at that time you use this plus sign, and whenever you calculate this minimum strain, so you apply this negative sign. Okay, so under bracket epsilon x minus epsilon y by 2 bracket square plus gamma xy divided by 2 bracket square. So this equation is useful for finding out maximum and minimum principal strains. Okay, got it?
Yes.
Okay, so next definition we will see principal plane. Already we have discussed, but once again we will see principal plane. Principal plane. So principal plane means the plane on which there will be no shear strain, no shear strain, no shear strain. The plane on which there will be no shear strain or zero shear strain, zero shear strain, zero shear strain. So shear strain will be absent or zero. Such a plane is called as principal plane. Okay, so how to find out this principal plane? Tan 2 theta, which is equal to gamma xy divided by epsilon x minus epsilon y. So this equation is useful for finding out principal plane. Okay. Please write down fast. So we will move towards next point. Okay, over.
Yes.
Okay, so next point we will see maximum shear strain. How to find out maximum shear strain. So please write down next point. Maximum shear strain. Maximum shear strain. Maximum shear strain. Maximum shear strain. So maximum shear strain gamma max, which is equal to epsilon maximum minus epsilon minimum. So epsilon maximum means epsilon 1 and epsilon minimum is epsilon 2. That is major principal strain and minor principal strain. So maximum, that is major principal strain minus minor principal strain, which is equal to maximum shear strain. So this is the equation for finding out maximum shear strain. Then next we will see principal strain from principal stresses. Suppose stresses are given and from that we have to find out strains. So this is the next important point. 2D principal, 2D principal strain, 2D principal strain from principal stresses, from principal stresses. So here suppose stresses are given. Suppose stresses are given and from that you have to find out strain. So at that time which equations are useful? So epsilon maximum, which is equal to sigma 1 upon E minus mu into sigma 2 upon E. Okay, so this is the first one. And epsilon minimum, which is equal to sigma 2 upon E minus mu into sigma 1 upon E. So these two equations, when we will use if principal stresses are given. Okay, principal stresses, Young's modulus and Poisson's ratio is given. At that time, you use this equation for finding out principal strains. Okay. So this principal strain point is not too much important. So we will solve only one numerical on that and then move towards next point. Okay, completed. Your writing is over.
Yes.
Okay.
So
So
1 minute, madam.
okay.
Okay, madam. Over. Okay, so now we will solve one numerical. So please write down. On a mild steel plate, on a mild steel plate, on a mild steel plate, a circle of diameter 50 mm, of diameter 50 mm, diameter 50 mm
is drawn. Is drawn before the plate is before the plate is before the plate is stressed before the plate is stressed as shown in figure as shown in figure as shown in figure. Full stop. Find the length of find the length of find the length of find the length of major and minor axis major and minor axis of an ellipse formed as a result of as a result of the deformation of the circle marked. Result of the deformation of the circle mark of the circle mark. Okay, so I will draw figure simultaneously. You can also draw. Okay, so here A, B, C, D plate is given. On that plate, one steel rod or steel shaft is provided having diameter 50 mm. Okay. Without stressing or before application of loading, here hole is observed. After that, after application of loading, as a result of this, deformation will be occur in that particular member. So this deformation indicates the shape of this circular shaft will be changed in elliptical form. And we have to find out the diameter of this ellipse is increased or reduced. So this is the question. Now we will solve. So you just observe figure and tell me which parameters are given.
सिग्मा एक्स मॅडम म्हणजे
epsilon x आणि epsilon y.
epsilon
Epsilon
x
x
आणि
is
x
80 आणि epsilon y is 20.
Okay, so first step we will write given parameters. Okay, so here first step epsilon x is given. Epsilon x which is equal to 80 Newton per mm square. After that next parameter is given, that is epsilon y. So epsilon y is 20 Newton per mm square. The next one is
सिग्मा एक्स वाय
no, tau is given.
Gamma.
Yes,
gamma
yes,
एक्स वाय
yeah.
मॅडम
So gamma xy is given, that is shear strain is given, and the value of shear strain is 40 Newton per mm square. Okay. So first we will calculate maximum and minimum principal strain values. Okay. So first we will find principal strains. Principal strain. So in that we got two values. First one is maximum principal strain and second one is minimum principal strain. So epsilon max, epsilon minimum, which is equal to, our equation is epsilon x plus epsilon y by 2 plus minus square root of epsilon x minus epsilon y by 2 bracket square plus gamma xy square. Okay, now we will put values here. So epsilon x, that is epsilon max, epsilon minimum, which is equal to epsilon x is 80 plus epsilon y is 20 divided by 2 plus minus square root of 80 minus 20 divided by 2 bracket square plus shear strain is 40 square. So first we will find maximum principal strain. So you use this plus sign and tell me what is the value of maximum principal strain.
Chamber.
Okay, 100
100.
Newton per mm square. Then next we will calculate minimum principal strain. So whenever we will find out minimum principal strain, at that time you have to use this negative sign.
Okay, so you calculate accordingly and tell me epsilon minimum, which is equal to how much?
0. 0.
Yeah, okay, 0 Newton per mm square. So these are the maximum and minimum principal strains. Okay. Now, so here these
Madam,
eight.
hello.
Yes.
मॅडम ती फॉर्म्युला चुकलाय का जरा का देताना चुकलं
Which equation?
हा तो
No,
हा
yes.
ते पुढचे रूट मध्ये
Epsilon x minus epsilon y is there.
डिवायडेड बाय 2 स्क्वेअर प्लस के
Gamma,
प्लस डिवायडेड बाय 2
Divided by
डिवायडेड
2
बाय
आहे
2 आहे
मॅडम.
ना
हा.
Yes, yes.
डिवायडेड बाय
Divided by
2
2.
आहे ना
gamma xy divided by 2. Okay. Okay. So I think answers are correct. Okay.
वेगळे ते 86.05 येते
86.05.
05
नाही मॅडम 100च येते.
Wait. I will tell you one correction here. So we have solved wrongly problem. So just wait. We will correct. Then we will solve problem. So in this question, the value of stresses are given. That so in this question here, value of stresses are given, not stress value given. Okay, so value of stresses are given here. So here sigma x is given, sigma y is given, and then tau is given. Because of in this figure, the values are given with respect to stresses. So these stresses are given. Okay. So now we will calculate maximum and minimum principal stress accordingly. Okay. So here find principal stresses. Find principal stresses. Find principal stresses. So now our equation is sigma 1 comma sigma 2, which is equal to sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 bracket square plus tau square. Because of in this question stresses are given, and due to these stresses, which or how much strain will be developed, that value we have to find out. Okay, so sigma 1 and sigma 2, which is equal to sigma x is 80 plus sigma y is 20 divided by 2 plus minus square root of 80 minus 20 divided by 2 bracket square plus 40 square. Okay, now you tell me sigma 1, which is equal to how much, and sigma
100.
okay, 100 Newton per mm square, and sigma 2, which is equal to 0 Newton per mm square. Okay, so these are the principal stresses. So if principal stresses are given, and we have to find out principal strains, so equations are available with you. So next step is find principal find principal strain. Find principal strain. So how to find out principal strain? If stresses are given, epsilon 1, which is equal to sigma 1 upon E minus mu into sigma 2 upon E. Okay, so in the question, take mu, which is equal to 1 by 4, and E, which is equal to 2 into 10 raised to 5 Newton per mm square. Okay, so now we will put values here. So epsilon 1, which is equal to sigma 1, that is major principal stress, 100 divided by E. The value of E is 2 into 10 raised to 5 minus mu. Value of mu is 1 by 4, that is 0.25. Okay. Into the value of sigma 2 is 0 divided by 2 into 10 raised to 5. So here this term will get 0. Okay. This term we will get 0. So accordingly you calculate the value of epsilon 1 and tell me epsilon 1 which is equal to how much?
5 into 10 to the power
5
minus
into 10 raised to minus 4.
Okay, wait. We will write 5 into
10 raised to minus
10
4.
raised to minus 4.
so epsilon 1 which is equal to 5 into 10 raised to minus 4. And unit of this, what is the unit of strain?
No unit.
No unit.
No unit.
No unit. So this is the major principal strain. Now we will find out minor principal strain. So for that we will use second equation, epsilon 2 which is equal to sigma 2 upon E minus mu into sigma 1 upon E, right? So we will put values here. So epsilon 2 which is equal to sigma 2 is 0 upon 2 into 10 raised to 5 minus mu. Mu is 0.25 into sigma 1 is 100 divided by E is 2 into 10 raised to 5. So epsilon 2 which is equal to
Minus 1.25 into 10 raised to minus 4.
1.25 10 raised to minus 4.
minus 1.25 into 10 raised to minus 4. So this is the epsilon 2. Now we got the values of principal strains. Okay, values of principal strains. Okay, so this plus value indicates diameter will be increased. Diameter will be increased. Okay, and this minus value indicates diameter is reduced. Diameter is reduced. So accordingly now we will find out diameters. Okay, accordingly we will find out diameters. So because of epsilon 1 diameter will increases. Okay, diameter will increases. This plus value indicates diameter will increases. Now you tell me strain which is equal to epsilon which is equal to epsilon which is equal to change in diameter divided by original diameter. Because of here we have to find out diameter na. So basic definition of strain which is equal to change in dimension divided by original dimension. Suppose length will be changed, at that time del L upon L. Suppose diameter will be changed, at that time del D upon D. That is which parameter is changed respectively we will take here. So here diameter is changed. So del D upon D. Now we have to find out change in diameter. So therefore, change in diameter which is equal to epsilon 1 into D, because of original diameter is given na, in question. So del D which is equal to epsilon 1. Epsilon 1 already we have calculated, and epsilon 1 is 5 into 10 raised to minus 4. Okay. So 5 into 10 raised to minus 4 into the diameter, original diameter of rod is given. This is 50. So therefore, del D which is equal to how much?
0.025.
0.025 mm. Okay. So this diameter is due to epsilon 1. Now we will check due to epsilon 2. Because of epsilon 2, diameter will reduce. Okay, reduce. So epsilon 2 which is equal to, same here, change in diameter divided by original diameter. Okay. So here we have to find out change in diameter, del D, which is equal to epsilon 2 into D. So del D, which is equal to epsilon 2 is minus 1.25 into 10 raised to minus 4, but already we have written here reduced. So now we will remove this minus sign. Okay. So 1.25 into 10 raised to minus 4 into original diameter is 50. So therefore, del D, which is equal to
6.25 into 10 to the power minus 3.
6,
6.25 into 10 raised to minus 3.
6.25 into 10 raised to power minus 3, which is equal to 0.0625 mm. 0.0625 mm. So this is due to epsilon 2. Now you tell me which diameter we will select. Okay, so here question is asked.
0.0625.
Wait. Find the length of major and minor axis. So we have to find out the length. So now we will find length. Here we got change in diameter. Okay, and original diameters are with you. So major axis, which is equal to major axis, which is equal to major axis, which is equal to. So what is the value of major axis, or how to calculate? Anyone guess, please? Major axis, which is equal to original diameter plus change in diameter. Okay. So original diameter is 50 plus change in diameter is 0.025. So which is equal to 50.025 mm. Okay. So 50.025 mm. And same way we will find out for minor axis. So minor axis, which is equal to original diameter minus change in diameter. So original diameter is 50 minus change in diameter is 0.0625, which is equal to 49.99375 mm. So this is the final answer. This is the minor axis length and this is the major axis length after stressed. Whenever we will apply stress on that plate, so this diameter will be increased along the major axis and reduced along the minor axis. So final length of major axis is 50.025 mm and the minor length of length of minor axis, which is equal to 49.99 mm. Okay, so please write down fast. This problem is not more important, but for your understanding I have taken. So please write down fast.
Okay, over. Yes,
1
right.
meter.
Over or not?
Not madam.
Okay, okay. Let me know after your completion.
Yes, ma'am. More.
Okay. So this is the principal stresses and strain over. Now we will move towards principal stresses in beams. So please write down next point. Principal stresses in beams. Next point is principal stresses principal stresses in beams. Principal stresses in beams. Okay. So first I will explain. Suppose we have taken this beam and we applied load here. So whenever we will apply load, after application of loading, here normal as well as shear stresses will be developed in that beam. Okay, got it? So due to this load, reactions will be there, VA will be. That is shear force is there. And due to this load, beam will be bent. So normal or bending stresses will be generated. So you remember that if beam is subjected to loading, then the normal and shear stresses will be developed in that beam. So whenever we will apply any type of load, due to this application of loading in that particular beam, there will be normal stresses as well as shear stresses will be developed. And now we have to find out, or we have to see how to find out this normal and shear stresses. So I request all of you, please write down first sentence. When a beam is subjected, when a beam is subjected, when a beam is subjected, when a beam is subjected to loading, subjected to loading, subjected to loading, then the normal stresses, then the normal stresses, normal stresses, then the normal stresses, normal stresses, and shear stresses, and shear stresses, and shear stresses, normal stresses, and shear stresses are induced. Shear stresses are induced. Shear stresses are induced. Full stop. The normal and shear stresses, the normal and the normal and shear stresses, the normal and shear stresses, normal and shear stresses acting at a point, acting at a point, acting at a point inside a, inside a, inside a loaded beam, inside a loaded beam, inside a loaded beam can be obtained by, can be obtained by, can be obtained by. So after application of loading, there will be normal and shear stresses generated. So how to find out? Okay. So first we will see normal stress or bending stress, sigma, which is equal to, already you know that, how to find out bending stress, sigma, which is equal to m into y divided by I. So this is the equation for finding out bending stresses. So sigma or sigma b, which is equal to m into y divided by I. So here
M which is equal to, M means bending moment. Okay, M is bending moment. M is bending moment. M is bending moment. M is bending moment. Then Y. Y means location of stress. Y is location of stress. That means at which point we have to find out stress. So Y is location of stress. After that, next is I. Now you tell me I which is equal to, what is
Moment of inertia.
movement of
Inertia.
inertia. Okay, movement of inertia. Moment of inertia. And sigma which is equal to bending stress or normal stress. Bending stress or normal stress. Bending stress or normal stress. Normal stress. So this is the equation for finding out bending stress. Okay, now we will see how to find out shear stress. Okay, now we will see how to find out shear stress. So tau which is equal to SAY bar divided by IB. SAY bar divided by IB. So this is the shear stress formula. This formula is shear stress formula. So by using this formula, we will find out shear stress. We will find out shear stress, and this equation is bending equation. This equation is bending equation. This equation is bending equation. Okay. So now you tell me the terms in shear stress formula. Okay, so this is the shear stress formula. So tau which is equal to SA y bar divided by IB. Yes, nothing but shear force. A y bar means movement of area. Okay, A y bar means movement of area. Tau is the shear stress. B is the width at the location where shear stress is calculated. Suppose we have taken this I section. Okay, I section, and we have to calculate shear stress at this point. So this is the width. At that width, we will calculate shear stress. So that's why we have written here width at the location where shear stress is calculated. Suppose asked to find out at the flange. So this is the width. Okay, so this width will be changed according to location. And the I, already you know that I means movement of inertia. Okay, so for that one diagram is available. So I request all of you, if your writing is over, shall I move towards next point? That is, I have to draw figure. Over writing. Or you want time? Yes, please. May I audible? No?
Yes, ma'am.
Okay. You want time or your writing is over?
1 minute, madam.
Okay.
Yes, ma'am.
Okay. So, or we have written here only one point. Whenever we will apply load, due to this loading, normal and shear stresses are induced. And formulas are written here for finding out bending stresses and shear stresses. Now, we will draw one figure here. Simultaneously, you can also draw. Suppose this is the cross section of beam. So here I have drawn three figures. In that first one, A figure indicates cross section of beam. This B figure indicates normal oblique bending stress distribution diagram, and this third figure, that is C figure, indicates shear stress distribution diagram. Now we will see. First, we will observe this normal or bending stress diagram. Okay, so you observe this. This is the neutral axis. At neutral axis, normal or bending stress is 0. You observe here the value of normal and bending stress at neutral axis is 0, whereas the normal or bending stress is maximum at outermost fiber. Maximum at outermost fiber. Okay, you observe here in bending or normal stress, maximum stress is at outer face and 0 will be at neutral axis. 0 at neutral axis. But in shear stress distribution diagram, the shear stress is 0 at outer face. Shear stress is 0 at outer face and maximum at neutral axis. Maximum at neutral axis. So definitely one MCQ will be asked on this stress distribution diagram. So please remember, bending stress or normal stress is maximum at extreme fiber and 0 at neutral axis, and opposite to this shear stress distribution diagram is there. Got it? बघा काय होतं, नॉर्मल स्ट्रेस हा आउटर फेसला जास्त आहे आणि न्यूट्रल ऍक्सिसला 0 आहे. तर त्याच्या अपोजिट म्हणजे शियर स्ट्रेस हा आउटर फेसला 0 आहे आणि न्यूट्रल ऍक्सिसला मॅक्सिमम आहे. तर याच्यावर एक डेफिनेटली एक क्वेश्चन विचारलेला असतो. सो नाउ वी विल राइट. Please write down the normal stresses are maximum at outer faces, and 0 at neutral axis. 0 at neutral axis. But shear stresses are 0. Shear stresses at outer faces. Shear stresses are 0 at outer faces and maximum at neutral axis. Maximum at neutral axis, or where normal stress is 0. Where normal stresses are 0. So this is the stress distribution explanation. Got it? Okay. Over. Your drawing is over. Writing also over.
Yes, ma'am.
Yes.
Okay. So now we will solve numerical. So please write down problem. The simply supported beam of the simply supported beam of 160 mm wide, and 240 mm deep, as shown in figure. Find the principal stresses. Principal directions and maximum shear at 2 meter from 2 meter end A from end A at the 80 mm depth 80 mm depth 80 mm depth from bottom 80 mm depth from bottom. Okay, so this is the question. Now we will draw figure. So this is the beam having width is given how much? 160 mm 160 mm, and depth is given here d, which is equal to 240. Okay, so d, which is equal to 240, and this is the beam. Okay, here roller support is provided. So on that beam, uniformly distributed load is applied, and the intensity is 8 kilonewton per meter, and span is 6 meter. Okay, so this is the beam. First, we will write given parameters and then we will solve problem. Okay, so first we will write given parameters. So here width of beam is given, B, which is equal to 160 mm, and depth of beam D, which is equal to 120 mm. After that, span L, which is equal to 6 meter, and load is applied P, which is equal to 8 kilonewton per meter. So we have to find out principal stresses and strains. So first we will find out RA and RB. Suppose this is A point and this is B point, and we have to find out the stress at 2 meter from A support. So this is our cross section. Okay, and at 80 mm depth So here we have to find out stresses. Okay, so first we will find RA and RB. So now you tell me how to find out RA, RB. Anyone? So first find reactions. So how to find out? Summation fx, which is equal to 0. So here RA, suppose this is RA and this is RB. So whenever we will apply summation fx equation, at that time vertical forces we will take positive and downward forces we will consider negative. So this RA and RB going upward direction. So RA plus RB, then this 8 going downward direction. So minus 8 into, this is uniformly distributed load. So 8 into 6, which is equal to 0. So RA plus RB, which is equal to 48. So this is equation 1. Then next equation we will apply summation moment at A point, which is equal to 0. Summation moment at A point, which is equal to 0. So summation moment at A, which is equal to 0. Now we will find out moment at A. So whenever we will calculate movement, please remember clockwise movement we will consider positive and anti-clockwise movement we will consider negative. So this RB creates anti-clockwise movement towards A point. So minus RB into movement means force into perpendicular distance. So RB is force and perpendicular distance is 6 meters. Okay. Then next force is this 8 kilonewton. So this 8 kilonewton creates clockwise movement. So plus 8 into. So 8 into 6 into it will act at 6 by 2, which is equal to 0. And here RA force is there, but for RA perpendicular distance is 0. That's why we will eliminate this. Okay. So minus 6 RB plus 2 1s are 2, 2 3s are 6. So 8 into 6 into 3. How much?
144, madam.
144, which is equal to 0. Now we will shift this 6 RB to right side. So 144, which is equal to 6 RB. Therefore, RB, which is equal to 144 divided by 6. Therefore, RB, which is equal to
24.
24 kilonewton. Once you get RB, then next RA, which is equal to, we will put this in equation 1. So put RB in equation 1. So what is our equation 1? RA plus RB, which is equal to 48. So our equation 1 is RA plus RB, which is equal to 48. So RA as it is plus 24, which is equal to 48. Therefore, RA, which is equal to 48 minus 24. Therefore, RA, which is equal to
24.
24 kilonewton. So these are the reactions, RA and RB. After that, we will draw free body diagram and we will find out shear force and bending moment. Next step is step 2. Draw free body diagram and find shear force and bending moment. Okay. So for that, we will draw figure here. So this is our suppose beam. Okay, this is our beam. So here, this is RA. This is RA 24. Okay. Here, now one shear stress will be created and here movement. Okay, movement will be generated due to this rolling support. Okay, and here uniformly distributed load is applied and intensity is 8 kilonewton per meter. Okay, and our distance is 2 meter. So now we have to find out stress at which point? At 2 meter. Whenever we will cut this beam, at that time one shear force and bending moment will be there. So now we will find out shear stress and bending moment. लक्षात आलं का बघा? काय करायचं आपल्याला की ए पॉइंट पासून 2 मीटर वरती आपल्याला काय घ्यायचंय सेक्शन घ्यायचंय आणि त्या 2 मीटर वरती आपल्याला प्रिन्सिपल स्ट्रेसेस फाइंड आउट करायला सांगितले. मग ते स्ट्रेसेस फाइंड आउट करण्यासाठी आपल्याला पहिले शियर स्ट्रेस आणि बेंडिंग स्ट्रेस फाइंड आउट करायचा आहे. तर तो फाइंड आउट करण्यासाठी आपण सेक्शन 2 मीटरवर घेतलाय. ज्यावेळी आपण एखादा बीम कट करतो आणि त्याच्यावर जर लोड अप्लाय होत असेल तर त्या लोडमुळे त्याच्यात नॉर्मल ॲज वेल ॲज बेंडिंग स्ट्रेसेस विल बी जनरेटेड. ओके, so now first we will apply first equation, that is summation FV, which is equal to 0. That means vertical forces, which is equal to 0. So whenever we will consider vertical forces, at that time upward we will take positive, downward we will take negative. So this 24 going upward, so 24 minus this 8 kilonewton going downwards, so 8 into 2, which is equal to 0. Sorry, one force is remaining. Which force is remaining? Minus
5.
No, this is yes, shear force. This S means shear. This is shear. So S, which is equal to 0. So therefore S, which is equal to 24 minus 16. So shear, which is equal to S, which is equal to 8 kilonewton. Shear force, which is equal to 8 kilonewton. Okay, now we will apply bending moment equation. So summation moment at A, which is equal to 0. We will take moment at A. So whenever we will take moment, clockwise we will consider positive, anti-clockwise we will consider negative. So this M is already movement. So here need not be multiplied by perpendicular distance. So M we will take as it is, and this creates clockwise movement. So M. Okay. Then this S creates again clockwise movement. So plus S into perpendicular distance is 2 meter. Okay. Now we will move towards this 8 kilonewton force. This is again creates clockwise movement. So 8 into 2 into 2 by 2, which is equal to 0. Okay, which is equal to 0. लक्षात आली आहे का बघा मुवमेंट कशी घेतली ते? Once again I will repeat. बघा हा मुवमेंट ऑलरेडी मुवमेंट आहे, त्यामुळे त्याला परपेंडिक्युलर डिस्टन्सनी मल्टिप्लाय करायची गरज नाहीये. हा एस जो फोर्स आहे शियर फोर्स, तो काय करतोय क्लॉकवाइज मुवमेंट क्रिएट करतोय, म्हणून आपण एस इंटू परपेंडिक्युलर डिस्टन्स किती आहे 2 मीटर. And this 8 kilonewton force again creates clockwise movement. So 8 into 2 into 2 by 2. Okay, so now we will put value of S here. So M which is equal to minus 8 into 2 minus 8 into 2 into 2 by 2. So you calculate and tell me M which is equal to how much? M which is equal to
minus 32.
okay, minus 32 kilonewton meter. So this minus sign indicates movement will be anti-clockwise movement. So our sign is incorrect. So this way we have to take sign. Okay, so movement is anti-clockwise movement. Okay, so now we got the value of S and M. Okay, next target is we will find out movement of inertia for this rectangle. Okay, so moment of inertia I which is equal to moment of inertia for rectangle is BD cube upon 12. So which is equal to B is 160 into D is 240 cube divided by 12. So I which is equal to
184.32 into 10 raised 6.
to 10 raised to 6 mm raised to 4. So this is the moment of inertia. Now we have to find out bending stress, and equation of bending stress is sigma b which is equal to m into y divided by I. So y is remaining. So y which is equal to. Now, okay, suppose this is our rectangular section. Okay, and this is neutral axis. So this depth is 120 mm. This depth is 120 mm. And we have to find out stress at 80 mm. We have to find out stress at 80 mm from bottom. So this remaining distance means y. So y which is equal to 120,
40.
120 minus 80. So y which is equal to 120 minus 80 which is equal to 40 mm. Now we are able to find out bending stress or normal stress. So bending stress sigma which is equal to m into y upon I. So which is equal to m. M is 32 kilonewton meter. We will convert into Newton mm. So 32 into 10 raised to 6. 10 raised to 3 for Newton and 10 raised to 3 for mm. Into y
Madam,
is
minus 32.
yes, this minus indicates movement is anti-clockwise. That's why we will neglect this. Okay. Divided by I. Moment of inertia is 184.32 into 10 raised to 6. So you calculate sigma b and tell me sigma which is equal to how much?
69.44.
69 or 6?
6.9.
6.94.
6.
6.94.
Newton per mm square. So this is the bending stress generated in that beam. Okay. Then next we will find out shear stress. Okay. Next we will find out shear stress. So how to find out shear stress? Anyone guess please? By using which equation?
Yes, SA Y bar upon IB.
Okay, find shear stress. So how to find out shear stress? Already we have written tau, which is equal to SA Y bar divided by IB. Okay, SA Y bar divided by IB. So already shear force calculated, moment of inertia also calculated, width already you know that. Okay, so what is remaining? Only AY bar. Okay, only AY bar. Okay, so this AY bar is remaining. So AY bar, which is equal to area of that particular section, which is equal to 80 into 160. 80 into 160 because of, बघा आता इथे थोडं मी एक्सप्लेन करते. तर आपला हा ओरिजिनल बीम आहे, बरोबर आहे, आणि हा न्यूट्रल ऍक्सिस आहे. ठीक आहे, तर आपल्याला स्ट्रेस कुठं फाइंड आउट करायला सांगितलंय हो?
80 मॅडम.
80 mm ला, म्हणजे इथं फाइंड आउट करायला सांगितलंय, बरोबर आहे, इथं या पॉइंटला. मग हा एरिया कुठला आला मग तुमचा? हा एरिया असणार आहे, राईट. ही विड्थ आहे. सो एरिया 160 into 80. नाउ वी हॅव टू मल्टिप्लाय बाय वाय बार. ओके, वी हॅव टू मल्टिप्लाय बाय वाय बार. सो वाय बार म्हणजे काय असणार आहे? तर याचा CG. ओके, याचा CG असणार.